Hello students, in our last class we were dealing with the various methods of preparation of alkyl halides, no? And our substrate molecule was alcohol. Two reagents have been used so far. One is halogen acid and second one is the phosphorus halides. Okay. Today we will use another reagent with alcohol in order to prepare alkyl chloride particularly. The reagent is thionyl chloride. A reaction with thionyl chloride. Let me write the chemical equation fast here. As I told you, substrate is alcohol. Reagent, that is thionyl chloride, SOCl2. When this reaction mixture be heated, as a result of the chemical reaction, you will get alkyl chloride, and the byproducts are sulfur dioxide gas and HCl. These are the byproducts. This reaction that can be catalyzed by some tertiary amines like pyridine or a triethyl amine. This kind of catalyst may be used in order to promote or just to enhance the rate of this reaction. Which catalyst? Pyridine C5H5N or triethyl amine. Triethyl amine C2H5 is ethyl group, triethyl amine, or this can be written as Et3N. So let me write here Et3N, triethyl amine. These gases, they are acting here as catalyst in order to promote or in order to enhance the rate of reaction. Okay. Let us discuss some examples first. I have taken N-propyl alcohol. When it be treated with thionyl chloride, SOCl2, you will get the corresponding alkyl chloride, N-propyl chloride, and the same side products, sulfur dioxide gas and HCl. Okay. Similarly, if secondary butyl alcohol be taken, let me consider isopropyl alcohol. This is also one of the secondary alcohol. Okay. When that be treated with thionyl chloride, you will get the corresponding alkyl chloride, isopropyl chloride. Isopropyl chloride. In the place of which just I need to put Cl and I can get my product. Okay, sulfur dioxide and HCl. So this is the chemical reaction, and the very important point related to this reaction is, if we need to prepare alkyl chloride from alcohol, then what have we done in our previous classes? We can use HCl as reagent. We can use PCl3. We can use PCl5. Also here we can use SOCl2. Out of these various reagents, the use of SOCl2 with alcohol to prepare alkyl chloride is most preferred over the reagents, means HCl, PCl3, PCl5. SOCl2 is preferred. Why? Because when SOCl2 be used with alcohol, the side products are SO2 and HCl. These side products, being gases, they can escape easily, leaving behind alkyl chloride. That means the separation of this desired product is easy. That's why the use of SOCl2 is more preferred over the other reagents like HCl, PCl3 or PCl5. This reaction is called as Darzen's method or Darzen's process. Okay. Another point related to this reaction which has to be noted here. If the reaction be carried out in the presence of pyridine, or triethylamine as the base catalyst, then the mechanism of the reaction is SN2. If we will carry out the same reaction in the absence of this pyridine or triethylamine catalyst, then the mechanism of the reaction that changes. Now the mechanism is SNI. Just try to get it. In the presence of these catalysts, the mechanism is SN2. And in the absence of catalyst, the mechanism is SNI. Substitution nucleophilic internal. SN2 is nucleophilic substitution bimolecular. 2, that was standing for bimolecular, SN2. This is nucleophilic substitution bimolecular, and SNI, this is substitution nucleophilic internal. These are two different mechanistic pathways. Let me take one example here. This is one of the alcohol molecule. Can you tell me what is the name of this alcohol? 1, 2, 3, 4. 4 carbons are there. To the second carbon, the hydroxy group is there. This is butane 2-ol. Butane 2-ol. When this reaction be carried out in two different ways. In the first way, let me take the catalyst, pyridine. See, what have I told you? The mechanism of the reaction is substitution nucleophilic bimolecular. And when in the absence of the catalyst the same reaction be carried out, then the mechanism is SNI, substitution nucleophilic internal. As a result of difference in the mechanistic pathway, you will get the products which are having difference in their configurations. What happen? SN2 reactions that occur with inversion in configuration, whereas SNI reactions, they involve retention of configuration. You will get your products. In these two cases, we will get the same product. Same product. In the place of OH, our product will contain Cl. This was butane 2-ol. Then we will get 2-chlorobutane. This should be our product. In the place of OH, we will get Cl. This should be our product. But we need to investigate the stereochemistry of this molecule. Due to difference in the mechanism of these reactions, in the first case, your product will have inverted configuration. Inverted configuration. That means you will get your product which will have the opposite configuration to that of your substrate molecule. This is your substrate molecule and this is your product. When the reaction be carried out in the presence of pyridine catalyst, mechanism is SN2, then configuration will be inversed. But when you are not using the catalyst, the mechanism of the reaction is SNI. What have I told? When the reaction will occur through this mechanism, there is no change in the configuration. You will get your product with the same configuration as that of the substrate molecule. This is your product molecule, which have the same configuration as that of your substrate. This is your substrate, this is your product. Here the configurations are same. This is called retention in configuration, but the product, the configuration of this product and the reactant, they are having opposite configurations. This is inversion in configuration. Just remember, in the presence of pyridine catalyst, mechanism SN2 and inversion in configuration is observed. Whereas in the absence of catalyst, the mechanism is SNI, retention in the configuration is observed. Okay.
We will try to find the mechanistic pathway of the reaction in Darzen's method. Okay. Alcohol, it be treated with thionyl chloride, then you will get the corresponding alkyl chloride, sulfur dioxide and HCl. These are the byproducts. When the same reaction that be carried out in the presence of pyridine catalyst, then the reaction occurs through SN2 mechanism. We will take the previous example here. This is your substrate molecule. Okay, this is your butane 2-ol. It be treated with thionyl chloride. This is the structure of thionyl chloride molecule. When these two species be taken together, this oxygen atom, alcohol, it will attack through its oxygen atom to this electron deficient center sulfur. Sulfur is surrounded with a number of electronegative atoms. Electron deficiency will be observed over sulfur. As a result of this attack, this pair of electron will be shifted to this oxygen fast. Then you will get the species where this oxygen atom will have positive charge and it is directly bonded to the sulfur. Now the double bond that will become single bond and a negative charge will appear over this oxygen. This sulfur, it is again attached to two chlorine atoms. Now, once again this electron that will be delocalized. Due to delocalization, when this pair of electron that will come to this side, then any one of these two bonds, sulfur chlorine, two bonds are there, any one of the bond will be broken. This chlorine will be eliminated out. Then after the elimination of this chloride ion, what you will get? This oxygen, it has positive charge. Sulfur, it is doubly bonded with oxygen, one chlorine left. Okay. If we are carrying out this reaction in the presence of pyridine, which is a base, this oxygen which is attached to hydrogen, this is acidic hydrogen. This hydrogen now, it can be easily eliminated in the presence of a base. Then pyridine, in the presence of pyridine, C5H5N, this pyridine base, it will interact this H plus ion such that this electron now will shift to oxygen. Then your next species will be sulfur is doubly bonded to another oxygen, here chlorine atom is there, plus the C5H5N molecule that is now with this H plus ion forming pyridinium, C5H5NH plus, pyridinium ion. Okay. In the previous step, a chloride ion was formed. Now this chloride ion that will act as the nucleophile and it will attack this carbon center. This is your substrate center, carbon center, in a direction opposite to that of the leaving group. Now this is your leaving group. It is your leaving group. The leaving ability of this group is more as compared to the simple OH group. Okay. So when Cl minus, it will attack this carbon center from the opposite direction. This is in accordance with SN2 mechanism. Okay. Then a bond will be formed between this chloride and this carbon, and this bond will be broken. This leaving group will be eliminated out. Then you will get Cl, which is bonded to the substrate center. Now you will observe inversion in configuration. This is your product molecule which has inverted configuration as compared to the reactant. Okay, if you compare the configuration of these two species, these two molecules, they are having opposite configuration, and this inversion in configuration, that is simply due to SN2 mechanism, right? What is your eliminated species? The eliminated species is O minus S double bond O Cl. This is the eliminated species, living group. Okay. In the next step, the last step, previously we have obtained pyridinium ion C5H5NH plus. It will interact with this leaving group O minus S double bond O Cl. As a result of their interaction, due to delocalization of this electron, in this way the electrons will migrate. Okay, Cl minus ion will be formed, and that will be interacted by this pyridinium ion. So you will get C5H5NH plus Cl minus pyridinium chloride plus O double bond S double bond O. This is your sulfur dioxide molecule. This is your sulfur dioxide molecule. This is sulfur dioxide gas. Okay, and here HCl, where in the first reaction we have shown HCl as another side product. SO2, that was the side product. HCl, this is another side product, but in the presence of pyridine C5H5N, this is a base and this is acid, they will form the salt. They will appear in the form of salt. This is pyridinium chloride. This has been shown here. Okay, so this is about the reaction when pyridine catalyst be used. Pyridine catalyst be used. Pyridine that has been used, and the mechanism is SN2. Okay, next we will understand the mechanism of the reaction in the absence of the base catalyst. We will take the same substrate molecule, butane 2-ol, this is your alcohol. When it be treated with thionyl chloride, the first step is same in both these cases. This alcohol, it will attack through its oxygen atom to this central electron deficient sulfur atom, such that this pi electron cloud that will be shifted to this oxygen. Then due to displacement of these electrons, you will get a species where this oxygen that will have positive charge, as it has given its electron to the sulfur. Sulfur, now it will bond it to the oxygen through single bond, and two chlorine atoms are there. Due to delocalization of this electron cloud, one sulfur chlorine bond will be broken. Let us consider this bond. After the release of one chloride ion, you will get the species where this carbon, it is to oxygen which contains positive charge. Now the sulfur, it is doubly bonded to the oxygen and only one chlorine left. Okay. In the next step, this chloride ion that will play the role of base, and that will interact this acidic hydrogen. When we were considering the reaction in the presence of pyridine, pyridine was the base who was taking this hydrogen ion. But here this chloride ion, Cl minus ion, that will interact this hydrogen H plus, and this electron pair will be shifted to this oxygen, such that you will get the species Now only oxygen is there, no hydrogen, and this oxygen is attached to one sulfur atom. This sulfur is bonded to one oxygen atom through double bond, and one chlorine atom is there. Okay. Next, you need to note here, because the point of difference is here. After the formation of the species, gradually these particular bond, carbon-oxygen bond, it becomes more polar. It has the polarity initially, but this group, presence of this group, that polarizes this bond to somewhat more extent, as a result of which gradually this bond will be broken. This bond will be broken. Then you will get CS3, CS3, CS2. Okay, this is, and oxygen that will have negative charge, sulfur that contains oxygen that is bonded through double bond, and one chlorine is there. Due to delocalization of electron, this electron will migrate towards the side such that this bond will be broken. And these chloride ion, right after the formation of this chloride ion will interact this carbon center containing positive charge. These steps are very fast. Okay. This bond will be broken. In the same time, this chloride ion will interact this carbon. This chloride ion will interact this carbon such that there is no change in the configuration about the substrate center. This is carbon that was attached to one hydrogen, CS3 group, one CS3, CS2 group. Now this carbon is bonded to this chlorine. Okay, this is your product. Plus this electron, when it be shared between this oxygen and sulfur, you will get oxygen double bond sulfur double bond O. This is your sulfur dioxide molecule. Okay. So which are the products? One sulfur dioxide molecule, one alkyl chloride, and previously we had found what? Cl minus and H plus. They will give rise to HCl. HCl. This is another product. So our side products are HCl and SO2 and the desired alkyl chloride. This is. So if we compare the stereochemistry of the product and the substrate, this is your substrate molecule, alcohol. And as a result of this reaction, finally we found this product. If we compare the configurations of these two species, then they are found to be same. The configuration that has been retained, this is called retention of configuration. And this mechanism is called as SNI mechanism, substitution nucleophilic internal. Internal, within the same molecule, the nucleophilic substitution is going on. This is the same molecule where this part is acting as the nucleophile. And this is substituting this part. This is your leaving group. So within the same molecule, the substitution is going on. That's why this is internal substitution nucleophilic or nucleophilic substitution internal. And as a result of this reaction, retention of configuration occurs. Okay. So from these mechanistic steps, what have we done? If this is your substrate molecule, alcohol, when it be treated with thionyl chloride, and when the reaction that be carried out in the presence of pyridine base, then the product will have inverted configuration. Inverted configuration because the mechanism is SN2. This is inversion in configuration. mechanism is SN2. And when the same reaction that be carried out in the absence of pyridine, then the configuration of your product that is same as that of the substrate molecule about the substrate center. This is SNI mechanism. Inversion in configuration, this is retention in configuration. Okay.